Well, this is a quick review of mid-semester test questions. Question 1 is showing the arrangement of the machines in the typical layout, and it is asking us which type of layout for arrangement of the machines this is. If we take a look at the diagram provided, we can see that different machines are located in different departments on the basis of process they are performing. For example, laces are located in one department, milling machines in other departments, and the same for the rest of the machines. So machines are located in different departments on the basis of process they are performing. So this is a representation of a process layout. A is the correct answer. Question 2, which of the following best describes the relationship between product variety P and production quantity Q in the manufacturing operations? On the basis of the materials we have in the teaching materials, we know that as production quantity increases, then variety decreases. So there is an inverse correlation between P and Q. So B is the best choice, which is representing an inverse correlation. Number 3, which type of factory operations is characterized by low quantities of specialized products, general purpose equipment, highly skilled labor, and requires maximum flexibility? Obviously, this is not the case for mass production when we are in need of high volume of production. This is not the case for full line production. Again, the volume of production is significant. And also, this is not the case for cellular manufacturing. We are in need of flexibility, and the other properties listed in this question for C, which is a low or job shop production. In this type of production, we are in need of flexibility and high level of expertise of the labor in order to perform different tasks on different types of production. And when parts come into production, each one of them requires different activities, different types of tooling, and that sort of things. So these are representation of low or job shop production when the volume of production is low, sometimes 1, sometimes less than 10. So generally the volume of production is low, flexibility is high, skill level is high. Question 4, in the typical breakdown manufacturing cost, which components account for the largest and smallest percentages? On the basis of the diagrams that are provided in the last slides of lecture 1, we can see that, well, it is parts and materials and also direct labor, which are respectively accounting for the largest and smallest percentages of the cost. So question 4, B is the right choice. Question 5, which of the following combinations correctly matches the iron phase with its crystal structure and transformation temperature? Well, in this question, we can see different types of actually phases and crystal structures. Ferrite, in A we have got ferrite with BCC crystal structure, which is the case at room temperature. Well, this is correct, of course. B, austenite BCC 912 degrees C. This is incorrect because austenite has got an FCC crystal structure. Delta iron FCC 1394, again another incorrect choice because delta iron has got a BCC crystal structure. So the right choice is A. Question 6. Which one of the following statements for a eutectic composition of an alloy is true? Well, in A, it says it has the highest melting point among all possible compositions for this alloy. This is obviously incorrect because it is the opposite indeed. B, it solidifies over a temperature range, which is not the case for eutectic composition. It solidifies at a certain temperature only. It represents in C, it says it represents a single solid phase. Well, this is also incorrect because a eutectic composition has got a laminar structure of different phases. And D, it solidifies at a single temperature, the lowest in the system. And this is, of course, the correct answer. So D is the correct answer to this question. Question 7. Principal ore used in the production of iron and steel are magnetite, limonite, hematite, and siderite that contain what percentage of iron? Of course, 50 to 70% of iron depending on grade, and something must be sitting in place of 2 is considered as the principal ore as it contains the highest amount of iron. As we discussed in the lecture materials, these types of iron ores contain 50 to 70% of iron, with hematite, which has got the highest content, and that is 70% iron. So A is the right choice. Question 8. In the context of alloying, which one of the following statements is incorrect? In A, it says alloying can increase hardness and strength. Of course, this is correct. In B, it says alloying always results in a single phase structure. Well, this is obviously incorrect because when alloying is in progress, if the solubility limit is exceeded, then a second phase will be formed, which is referred to as intermediate phase. So B is incorrect. C, intermediate phases form when solubility limit are exceeded. This is what I just explained. This is correct. And these solid solutions involve atomic level mixing. Of course, this is true. So the only incorrect sentence is B. Next question. Which one of the below statements is incorrect? Well, this is about welding, of course, because of the picture. The weld interface has the same composition as the base metal. This is correct because the weld interface, as we can see in this figure, is melted, but before it is mixed with the filler material, it is solidified. So it remains the same. It remains with the same composition, which is the base metal. B, fusion zone is stronger than HAZ. This is correct because fusion zone is an alloy of the filler material and the base metal, so it is stronger than HAZ. C, HAZ is an alloy of the base metal and filler material. This is incorrect. Reason is that HAZ is only the base metal. It is not mixed with the filler material. It is only heated up and cooled down. So C is incorrect. And D, HAZ is weaker than the base metal, unaffected by welding heat. This is true. HAZ is subjected to actually thermal tension, and it has got residual stress in it. So it is weaker than the base metal, which is not affected by, say, by heat. So the only incorrect statement is C. Next question. In the arc welding processes, the electric energy from the arc process produces a temperature about something in 1, and this is hot enough to melt any metal. However, in oxy-fuel gas welding, the temperature of inner cone is about number 2 something else, providing a significantly lower temperature and putting a limit on the range of materials to be welded. What sits in place of 1 and 2? A is giving us the right answer. The temperature of arc welding is 5500 to 6600 degrees C, and the maximum temperature of the inner cone is about 3500 degrees C on the basis of teaching materials. So A is the right answer. Question 11. In resistance spot welding, which one of the following best describes the sequence of operations? Well, in A, apply current, apply force, remove electrodes. Well, doesn't make sense to apply current before applying force, so this is incorrect. B, insert parts, apply force, apply current, stop current, and remove electrodes. Well, this is showing the right sequence of operations in spot welding. C, insert parts, apply current, apply force, and then remove electrodes. Well, this is another incorrect arrangement of the activities because we need to apply force and then apply the current. And indeed, applying force before inserting parts obviously is incorrect. So this is not correct. So 11, for 11, B is showing the right sequence of operations. Question 12. Which one of the following operations combines both forming and generating actions, and what is the implication for the tool design? Well, A says thread cutting requires shaped tool and control feet. This is correct because it's the tip of the cutting tool which is cutting the actually material, and also the feet trajectory is left on the workpiece material which is giving us a spiral thread. So A is correct. B, face milling requires high speed inserts. Well, this is not correct. This is not actually in agreement with what is in the statement of the question. C, reaming requires multi-point cutting edges. This is correct, but not in agreement with what is in the statement of the question. And D, spot facing requires flat bottom drill. Well, again, this is not in agreement with what was in the statement of the question. So the right answer, of course, is A. Next question, question 13. Which machine tool type is presented in this figure? Obviously, this is the radial ring capable of moving the tool to the desired position. So A is the right answer. B, upright drill press, this is not the case. C, vertical milling, this is not a vertical milling machine. And D is representing gang drill, which is not the case in this figure. So A is the right answer. Question 14, which type of machining operation is this? Well, obviously, this is a face milling operation when the axis of rotation of the cutting tool is perpendicular to the surface being machined. So A is the right choice to question 14. Next question, question 15. Which one is incorrect? Well, in conventional milling, the cutter tends to lift the workpiece from the machine. Of course, machine table, this is correct. B, in climb milling, the cutter speed direction is opposite the feed direction. This is not correct. This is incorrect statement B. C, climb milling results in longer tool life. That is correct. And D, conventional milling is used for finishing operations, and this is also correct. The only incorrect sentence is B, on the basis of teaching materials. Question 16, which one is incorrect? 4 common methods of work holding in turning operations are A, between centers using dog. Of course, this is correct. B, 3-jaw choke. This is the most common type of holding the workpiece on the lathe. C, wise. Well, this cannot be used because this is used in other types of operations such as milling and not turning. So C is incorrect, and D, faceplate for non-cylindrical parts, and that is correct. So C is the incorrect actual choice. 17, question 17, a good surface finish with continuous chip as shown in this figure is likely to form when workpiece material is 1 and tool chip friction is 2. What sits in the places of 1 and 2? Well, because this is showing a continuous chip, this is the type of the chip that is produced when we are producing cutting ductile materials, and when obviously the other choice for 2 is a low cutting speed. So D is the right choice, which is giving us the combination of ductile and low for M2 places 1 and 2. Question 18. As shear plane angle decreases, cutting forces, power, and temperature increase. This is correct. This is on the basis of the materials we discussed in the machining theory, and as shear plane angle increases, cutting forces, power, and temperature decrease. But this question is presenting this in the reverse order. As shear plane angle decreases, this is not desirable. Then, of course, cutting forces, power, and temperature all increase. Obviously, all the other ones are incorrect. Next question. Question 19. A finishing operation generally involves which one of the following combinations of cutting conditions? V represents cutting speed, F feed, and D depth of cut. Well, for finishing operations, as it was discussed in the lecture, we are interested in high values of cutting speed but low values of feed and say depth of cut in order to produce a high quality surface finish. So C is giving us the right combination of parameters for finishing operations. Question 20. The figure shows changes in the geometry of chip in a turning operation when cutting a low carbon steel material. Which machining parameters are presented by axes 1 and 2 respectively? Well, in axis 1, as you can see, the width of the chip is increasing as we move from bottom to the top. So this is representing the depth of cut. And in the horizontal axis, as we move from left to right, then the length of the chip is decreasing. So 1 is representing depth of cut, and 2 is representing the feed. So B is the right choice. Question 21. Which one is incorrect? Crater wear occurs on the top rake face of the cutting tool. This is correct. B, flank wear occurs on the side of the cutting tool. This is correct. C, reduction of cutting speed or feed rate reduces both crater and flank wear. That is correct. So none of the above are incorrect. So we go for choice D, because all the sentences provided in A, B, and C are correct. So we choose D. Question 22. Which type of tool failure is considered most desirable and why? A, fracture failure. It indicates high toughness. B, temperature failure. It allows high-speed machining. C, gradual wear, it maximizes tool life. And D, greater wear, it improves chip flow. Which one is more desirable? Of course, it's not fracture failure because it is actually resulting in premature failure. Same for temperature failure. So C is providing us with a desirable mode of failure, and that is gradual wear, which maximizes the life of the tool. And D, greater wear, it improves chip flow. That is incorrect. So the right choice is only C. Question 23. What equation is this? Well, this is the famous Taylor's equation for tool life, which is relating tool life to cutting speed, and we properly discussed this in actually cutting tool lecture. So obviously C is the correct answer, Taylor's tool life equation. This is a very famous equation indeed. 24, which one is incorrect? The following criteria are generally recognized to indicate good machinability. A, zero shear plane angle. Well, that is not possible at all. So A is giving us an impossible scenario. And then B is of cheap disposal and good surface finish. C, long tool life. And D, low cutting forces. So we've got to find the incorrect choice, and that is obviously A, which is giving us an impossible scenario. Question 25, a machinability rating of 1, inside of the bracket 1 I mean, is used to indicate the machinability of the base material, and therefore A, inside of the bracket 2, MR, which stands for machinability rating, indicates a better machinability. What should be sitting in the places of 1 in the bracket and 2 in the bracket? Well, as a machinability rating of something is used to indicate the machinability of the base material. What is it? It is 1 on the basis of the teaching materials. So 1 is sitting in the place of number 1, and then higher is sitting in the place of number 2. So D is giving us the right combination of substitute words for numbers 1 and 2 in the sentence. So we can reread the sentence this way. A machinability rating of 1 is used to indicate the machinability of the base metal, and therefore a higher machinability rating indicates a better machinability. So D is the right choice. 26. A, something is sitting for 1 tool nose radius, and A, something else sitting in the place of 2 feed result in achieving a higher surface roughness. What combination of the words given makes this a complete sentence? 26. Well, on the basis of teaching materials and also experiments we performed in the lab, we know that a smaller tool nose radius and a higher feed result in a higher roughness. So we will go for a B. B is the best choice. Question 27. Which one shows the correct terminology for a close sand casting mold? We've got 3 sections identified by 1. The conical section is indicated by 1, and that is representing down sprue, of course. We've got number 2, which is the riser, and we've got number 3, which is the core. So the down sprue, riser, and core in the given order make this a complete sentence. So For question 27, A is the best choice. Next question, 28. Which one is incorrect in casting processes? The riser provides the supply of the liquid molten metal to the main casting during solidification. This is a correct statement. B, the riser must be designed to freeze after the main casting to satisfy its function. That is also another correct statement. C, actual size and shape of the cavity must be slightly enlarged to allow for shrinkage of metal during solidification and cooling. Well, this is also a correct statement. And D, in sand casting, cores are made of a low melting temperature material so that it can easily melt. This is incorrect because we don't want cores to be melted. We want them to be there in order to produce hollow shapes and internal shapes. So D is incorrect. Question 29. The left figure presents the green structure resulting from the casting for 1, and the one on the right belongs to 2. So how can we complete these this sentence properly? The combination of the actually words or phrases provided in A make this a complete sentence. The left figure represents the green structure resulting from the casting for a pure metal, and the one on the right belongs to an alloy. So we go for A, which is us, giving us the right actual choices for making this a complete sentence. And the last question, which one best explains the primary function of external chills in casting? A, encourage rapid freezing of the molten metal in a thin section of casting. Well, this is correct. B, reduce the solidification time of the entire mold. It will have this function to some extent, but this is not the primary function. C, reduce the filling time of the entire cavity. This is not the case at all. And D, eliminate cold solidification to achieve a homogeneous microstructure. This is not the primary function of using chills. So the right answer is A. Thank you.